We are looking at the chapter 7 permutations and combinations of class 11th. First of all, what is permutation and combination? You might have heard of your seniors speaking about or using this phrase in the sentence that will try all the permutation combination. Please try this permutation combination. In a similar manner, if just take an example that you have a suitcase with a number lock and there are four wheels here and the number are from 0 to 9. So how what you can do if you remember say one of these, you have to list all these. You have to list all these, write all these numbers say from 0 to 9 and try and find out what will be the proper choice if you just forgot this. And this task seems to be somewhat tedious, but we will try in this particular chapter to solve this thing and see how we can solve all these using very important aspect of arranging and selecting objects as required. So there are two things which are involved. First thing is arrangement, and second thing is known as selection. So arrangement pertaining to the permutation or choosing a selection pertaining to the combination, right? So what is the fundamental principle of counting? You might have known by now that when we compute or when we say table of any number, we are actually doing what? We are counting. So just assume that Mohan has say 3 pants and 2 shirts. So how many different pairs of pant and shirt can he dress up with? So how many ways are there? Let me go to the diagram and then we'll see how it can be. See, these are the 3 pants he can choose. For every pant he has an option of 2 shirts, similar 2 shirts. So there are in all 6 possibilities. So there are 6 pairs of these options which are available to him. So this is 6 actually we are talking about. Now one more example we take. This is the box, okay, tiffin box. This is the water bottle W, and B is tiffin box, T is water bottle, and the W. These are the possibilities. So what says Shubham? He is going to choose 2 school bags, tiffin boxes, and water bottle. What is the possibility of this arrangement actually? So he can have 2 bags. With every bag, he can have these 3 tiffin box and this water bottles. With every this T. So he has in all 12 possibilities. These are 12 possibilities. And this is actually the fundamental principle of counting. What you have done is when you multiply some element, say 3 into 5, you say 3 into 5 means 3 added 5 times. This is nothing but 3 into 5. So if an event occur in m different ways, and following which after this event another event occur in n different ways, then the total number of occurrence of event in this given order is m cross n. We can generalize it for various events like m cross m, n cross p, like this. If you have m followed by n followed by your p. So we have seen 2 problems by now. First problem, it was wearing or choosing pant and shirt. Second was choosing school bag, tiffin box, and water bottle. So in both the cases, we can have various possible orders. So we are talking about the orders or the arrangement. So we need to choose any one possible orders and count the number of different ways of occurrence of the events in this chosen order. For example, we need to find out the number of 4-letter words which can be made from ROSE with or without meaning. With or without meaning. Where the repetition of letter is not allowed. So what we can do here is we can make 4 boxes. choose any of these. So any of these can be chosen because these are 4. Any of these can be chosen in 4 ways. So once any of these is chosen, this is filled. Now 3 is remaining. So this box can be filled by any of the 3 remaining when the repetition is not allowed. Then when 2 are chosen, only we are left with 2. So this can be chosen in 2 ways. Only 1 is remaining, so 1 can be chosen. So 4, 3, 2, 1. So multiply it. This is 24. The required number of words is 24 if the repetition is not allowed. But if the repetition is allowed, then the first can be chosen in 4 ways because 4 options are available. For next also 4 options are available. R, O, S, E, all. So 4 can be chosen. So 4 into 4 into 4 into 4. 4 into 4 into 4 into 4, that is 256. Now we have say a flag kind of situation. So we have 4 flags of different colors. How many different signals can be generated if a signal requires to use the use of 2 flags, one below the other? So if you want this one below the other, then what? You have 2 flags together always. So you have in all what? 1, 2, 3, 4. 4 options are there with us. And with these 4 options, first you have 4 options and then you have 3 options. Because there will be as many signals as there will be way of filling 2 vacant spaces in succession by the 4 flags. You have 4 flags and there are around 4 ways you can choose it. And then you have the lower vacant with, you have 3 possibilities of choosing it, remaining 3 different flags. So you multiply 4 by 3, that is 12. This is your going to be answer. Next is how many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated. Now this question is will be used, this concept will be used quite often. If you want even number, you should have the last number, or you can say the place where it decides it is even or odd. So it can have only 2 or 4, right? So the unit place, this is unit place. Unit place can only be filled with 2 and 4. And this can be done in how many ways? Because only 2 and 4 can be chosen. So this can be done in 2 ways. But the rest can be taken. These are the 5 numbers. So rest can be chosen in any ways. These are 5 numbers. Anyone can be chosen. So these are 5 ways. So 5 into 2 is what? 10. So this is the answer. And find the number of different signals that can be generated by arranging at least 2 flags in order. 2 flags in order, one below the other. So these flags are order one below the other on a vertical staff. So if 5 different flags are available. Now a signal can consist of say either 2 flags or 3 flags, or say 4 flags and 5 flags. And now just count the possible number of signals which are consisting of 2 flag, 3 flag and 4 flag, 5 flag. So if we start with this 2, see, if we start with this 2, so there will be as many as 2 signal flag as there are ways of filling of 2 vacant places in succession by the 5, because there are 5 available. So you have 5, okay, then you have 4. The multiplication rule is, if 5 is available here, next available is 4. In the similar fashion for these 3, this is 5, this is 3, 4, this is 3. And the similar fashion 4, 5 in this manner. So when we combine this 2 flag, 3 flag, 4 flag, 5 flag thing which we just found it here, then this will be 20 plus 60 plus 120 plus 120, that is 320. Now we come to the permutation. What exactly permutation means? Permutation is the arrangement. Like the word rows we have seen, ROSE is one arrangement, REOS is one arrangement. These are all arrangements. So each arrangement is actually called the permutation of, say, these 4 different letters taken all at a time. All at a time. For example, just take this word number. Now, how can you choose 3 words or 3 characters or 3 letters from this and make another word with the meaning or not meaning? So number, you can choose NUM, you can choose MUN, you can use NUV. All these you can choose. Any of these you can choose. So the required number of words is what? First, you have these 6 at your disposal. So you can choose all these 6. Then one you have already taken, means 6, any of these 6. So only 5 is left. So you can choose next one is 5, next with 4. So if you have to choose 3 from this, 6, 5 into 4, 6 into 5 into 4, there are 120 ways. But if you are said that okay, the repetition is allowed, so first can be chosen in 6 ways, the other can be chosen in 6 ways, and next can be chosen in 6 ways. This is how 216 will be the answer. So the permutation is actually the arrangement in definite order of a number of objects taken some or all at a time. So it's arrangement in definite order. So the permutation, when all the objects are distinct, the number of permutation of n different objects, if we take r at a time, which r should be between 0 and n, is nothing but n minus 1, n minus 2 till n minus r plus 1, which is denoted by npr. So there will be, let us go to the proof. If you have a r vacant place, these are the r vacant place, you have n objects, so the first place can be filled in how many ways? Because there are n, there are vacant place, so n ways. Then next will be n minus 1, then n minus 2. So it goes up to the r minus 1, means n minus r minus 1 ways. So ultimately the number of ways of filling the r vacant space in succession is n minus 1, n minus 2, n minus r plus 1. And the expression this npr is can be cumbersome, but we'll introduce the symbol of factorial n here. Factorial n you can write like this. So the notation, this factorial n actually represents the product of first n natural number, that is 1 to that number. If you want to find out the factorial n, 1 to that number we can find out. So just read this symbol n factorial like this. N factorial is n minus 1, 4 till 1. So 1 factorial is what? 1 factorial. 2 factorial means 2 into 1. 3 is 3 into 2 into 1. So you start with that number and go up to 1. Right? Like 4 and factorial 0 is 1. This is very important. Factorial 0 is 1. What about factorial 5? It is 5 into 4 into 3 into 2 into 1. So in general, factorial n is n minus 1 factorial. And this n minus 1 can be written as n minus 1, n minus 2 factorial. This can be written as n minus 3 factorial like this. So if you want to evaluate factorial 5, you start with 5 till 1. Multiply all the numbers. For 7, start with 7, multiply till 1, 5040. Factorial 7 minus factorial 5, take this value, subtract them. Factorial 7 by factorial 5, you know factorial 7 is what? 7 into factorial 6. This can again be written as 6 into factorial 5. You can cancel out this factorial 5. And now, only 7 6 are 42 is remaining. What about factorial 12 by factorial 10, factorial 2? 12 into 1, take it out because only factorial 10 will be remaining. Cancel it out. So 2 is there. 2 6 are 12, 6 11 is 66. This is how the answer will come. If you want to evaluate the factorial n by factorial r, n minus r, n and r are given, place the value. And you see this 5 factorial 5 can be written as 5 into 4 into factorial 3. This get cancels. This is 2. So 2 to the 4, 5 to the 10. 1 by factorial 8, 1 by factorial 9, 1 by x by factorial 10. So what we do here is, we see that this number, when we find out the factorial, the number decreases. So this 10 can be written as, factorial 10 can be written as 10 into 9 into factorial 8. 9 can be written as 9 into factorial 8. Factorial 8 get cancelled. So this will be 1. This is 1 by 9 and this is x by 9 to 10, that is x by 90. And you can find out x, that is 100. So this is the first part of our discussion of permutation combination. We'll be taking more. Thank you so much. Take care.